Do your math homework. All right. So, in this chapter, we are going to work on integration techniques. We are going to work on more problems involving the L'Hopital's rule. We really only saw 1 out of like 7 cases, I think, for L'Hopital's rule. And then improper integrals. Okay?
He's not even writing anything.
Yeah, he's writing the square root.
Yeah, but look at the square roots above it. He doesn't have anything underneath the square roots.
What's in there?
Square.
What the? Now I don't know what it said on the first slide. Improper English.
You need to know your basic rules. Okay? On page 508 are a list of all the basic rules you should know, including these inverse trig ones that you know but don't remember, but now you really need to remember them.
Yep. I'm gonna write this down.
You? Why is not X? You can do X. I'm just trying to mimic your book, okay? I will tell you that arcsine and arctangent are the 2 most important ones, okay? You know that from AB last year. But what we need to be able to do is recognize patterns. When should we do this? When should we do something different? And that's what we're going to work on the next slide. The difference between the different techniques that we know.
So we have to know the arcs you can think.
Pick the pup up. Raise the bar high.
So how many total are there?
Well, you should know all the ones on 508.
Oh, okay.
Those are like the tangents and you know.
Ah, is this like a foreshadowing we're gonna have? How come this is?
Did you say no? What? Pop quizzes?
Yeah.
Watch me. I'm gonna be right.
Stressed all the time.
Okay, we're going to do these 4 examples. 3 that have the number 4 in it. We're going to do these 3 examples. So you see how they all look very similar,
Yeah.
but they're all confusing. Okay? 4 over blah, 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 4x over blah, 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 4x squared over blah, blah, blah. Okay? So let's start with 4 over x squared plus 25. Does that follow a pattern that we know? It looks like arctangent. Okay, so what I'm going to do for you, we could rewrite this as, just to help you see the pattern, x squared plus 5 squared, right? So, we have 4, it's a constant, it can be moved out front, right? But then the arctangent rule is 1 over a times the arctangent of x over a plus c. That's a c.
That looks like a row.
Does that make sense? Okay. Now, let's talk about the difference with number 2. Now we have for x over x squared plus 25 in our interval. What technique do we use here? Can we follow the arctangent rule?
No.
No, because there's an x in the numerator. However, there's an x squared in the denominator. What technique that you've done a lot can we use? Yes. I can see that the derivative of x squared plus 25 isn't the same, but differs by a scalar, multiple scalar. So we can let u be x squared plus 25. Try that again. Du equals 2x dx. Okay, well we have 4x dx. So let's talk about that. 2x dx gets replaced with du, which means there's still a 2 left over. And u is our denominator. It's never going to get old, is it? Okay, so our antiderivative is 2 natural log of the absolute value of u. Now, it is not important whether you put the absolute value bar on x squared plus 25. Why? X squared plus 25 is always positive, so it's not necessary to put it on there. It's kind of being redundant. I don't care if you are redundant. I'm just fine with it. Okay, but I just want you to know that it's not a big deal in this case. Right.
Are we ever going to have to work with derivatives and imaginary numbers together?
Nope.
Does that thing exist?
Yes.
No, it's okay.
I don't know if I can tell you. I don't remember working with imaginary numbers in calculus. But I didn't do anything with engineering. But I wouldn't think that that would be something that engineers would need.
Yeah, because it's not really
What if you go, or if you want to become a college professor in math, you have to do theoretical math. That's where you get into stuff like that.
Right. Okay, now this third example. What the heck do we do for this third example?
Oh, wait, oh, you do the, no, you can't do that.
We're about to learn.
If this were a limit, we could. This fraction, what's larger, the denominator or the numerator? The numerator is larger, which means this is an improper fraction. And what can we do with improper fractions? Like how, if I had 9/5, that's improper. How?
By separating out the lines.
And you do that by doing what operation? Hello!
Finish your program, your problem.
Are you sure? Yeah. Okay.
Finish your problem first.
It's an improper fraction we can divide. Right? 9 divided by 5 is how we get the mixed number. Right? So we have 4x squared plus 0x plus 0 divided. What?
I don't know how to do this.
Okay, guys, this is like the easiest division ever. X squared times what is 4x squared?
4.
Okay. 4x squared plus 100. If we do the subtraction, we're left with negative 100. That's our remainder. How do we write quotients? We have 4 minus 100 over x squared plus 25 dx. Okay, so if it's an improper fraction, we can divide to break it up. Now we can use our techniques. What's the antiderivative of 4? Way to correct yourself there. Okay. Now we have minus. What pattern does this follow? Arctangent. So we have 100 times 1 over a arctangent of x over a plus b. Okay, we're going to take a brief timeout for Kelly Malone and Miss Mead to talk to us about the UNO stuff.
So we'll
Okay.
make this easy. How many of you have already heard me today?
Isn't the senior breakfast on like May 9th?
It's on the Wednesday before.
Yeah, so we're gonna miss the senior breakfast if you're.
Well, but what's your last day of school? Like when's graduation?
I don't know. But
I am
think
not
the
sure.
last day that we actually have to like be in class is Wednesday. But like I'm not here. I'm curious that.
Wait,
I don't know if I think your graduation is the 13th, which would mean your breakfast would be the 9th.
Yeah, so we're gonna miss it. I'm gonna miss it.
Not for this.
No, for English.
Oh, okay.
That's why you
And
take
then-
regular English.
Yeah.
So
All right.
we're
I want to do this example. Write it down,
yeah, that's still one.
please.
Is that the last example?
There's going to be more.
Okay, so. If I can do this.
Now, there is not a relation to what's underneath the radical and its derivative compared to the numerator. Do you agree?
Yep.
Okay. Is there a different pattern we could fall back on? Okay.
Yep.
Yeah.
Okay, so do you agree? Actually, I'm going to write this as 5 squared. We can write our denominator as 5 squared minus 2x cubed squared, right? And then we kind of have the pattern of arc sine. Do you agree? All right, so let's do this. Let's let u equal what? 2x cubed, which means du is 6x squared dx. So what we have is 1/6 du over square root of 5 squared minus u squared. So our antiderivative is 1/6. What's this antiderivative? Arc sine. And u, are you guys okay with me putting 2x cubed over a plus c? Sound good? put a problem on the board, and I'm gonna give you and your neighbor 1 minute.
So that 1/6 doesn't go to the C? Like, it should be the C.
Well, 1/6 times C is still a C, so
Yeah.
it wouldn't matter. Does that make sense?
So whether you like have a conditional condition or something,
Right.
what would you do with that? Doesn't that make a difference?
It does. Like this is the antiderivative as a whole plus C. The only time it would matter is if there was like something on the other side, like a 2y
Yeah.
that you had. Does that make sense?
Yeah.
Okay. All right, you have 60 seconds to get me this antiderivative. So pay it up. Isaac, compare your answer with the fellows next to you. Pods 4 and 6, compare your answers.
Plus C. Squared plus C. C.
That's what I heard from somebody. I think Austin. Agree? What technique did you use? Okay. Good. Next one. I'm going to give you another 60 seconds for this one. What technique are you having to use? U substitution. Okay, what is your U? You're going to have to let U, it is weird, equal the natural log of cosine because your derivative is 1 over cosine times negative sine of x dx. Oh, look at that. What is that? That's negative tangent, isn't it? So we have negative integral of u du.
That seems too easy.
Right?
That threw me off.
So negative 1/2 u squared plus c. Awkward, right? Completely awkward. Yeah. Isaac, is that all right?
Yeah, I get it.
Okay. Just not happy about it?
Yeah.
Okay. Peter, same feelings?
What?
You all right with it?
Yes.
This?
I'm all right.
Okay.
Thank you for asking.
You're welcome. Okay, this looks very similar to what we had on that first page, but it's a little different. What pattern is it following though? Our tangent. Now, what I want to reiterate is if you have something that isn't just x squared, you're going to have to use some u substitution, okay? So since this is not simply x squared, it's 2x squared, we want to let u equal that 2x. Now, in this case, it's just a constant that we have to worry about. But in the case that we had before, it was like 2x cubed, the quantity squared. Okay, we just have to be careful in those types of situations. So, I want us to take the antiderivative of 1/2, the integral of 1 over 5 squared plus u squared du. Okay, so we end up with 1/2 times 1/5 arctangent of u over 5 plus c. And if you want to write that as 1/10 arctangent of 2x over 5, that's fine. I'm not going to make you multiply it through, but you can. The book's going to have 1/10 arctangent of 2x over 5. Okay, so your homework, which is on your gold sheet, this right here.